Okay, so just to review today in calculus, we just want to look at some basic transformations. So on the agenda, we have this paper linked under today's date next to this video. And we just want to just make sure that if we have one of our simple basic functions that we talked about yesterday, a square root of x, the sine of x, and there's some simple transformation made, that we might be able to use that to get a really quick sketch of the graph. Okay, so really the three transformations we're going to look at is a horizontal translation, moving from side to side, vertical translation, moving up and down, and then a reflection over the x-axis where the whole function goes from positive to negative. You know, y equals x squared to y equals negative x squared. Just makes all the outputs the opposite. So as we look at this, if in the original function you have an x and now you have an x minus a, that every x got pulled out and replaced with an x minus a, that means that the new graph will have moved a units to the right. Okay? It seems counterintuitive. I don't know what to tell you. But think about most functions, or something interesting happen when you get a zero in the function, correct? Like the square root of zero, or 0 squared, or 0 cubed. Well, if you're going to get a zero in there, you're going to have to actually put a in if you have x minus a, as opposed to just 0. So that's what's going on there. If x is replaced with x plus a, you moved a units to the left, and we'll look at an example or two here from the worksheet and see what that looks like. If we add k to the entire function, I guess I could have put entire, but if you add k to the function, we move the whole thing up k units, right? Y equals x squared, y equals x squared minus 2. We just moved it down 2 units. I didn't see how I was going to go up 2 units from here. It didn't look like it was going to go well. Okay, but that's what we're doing. So that's if you add a 2 or you subtract a 2, right? If you add a number, it makes it go up higher. If you make a number go down, it makes it go lower. On our quiz, we had a sine function that had like 75 plus, right? Well, that tells me the midline's at 75, and the sine function's oscillating around it. It's just a transformation. The other one that comes up a lot is if we make the entire function negative, we reflect it over the x-axis. What you did is the entire function is the y value, correct? So if you take all the points and you make the y value negative, well, if they were above the x-axis, now they'll be below, right? Because a positive y just became a negative y, or vice versa, a negative just became a positive. Okay. So let's describe the translation and just state the domain and the range for some of these problems on this worksheet. So for number 1, we have f of x equals the square root of x plus 5. And remember, we'll talk more about this tomorrow or the next time I see you, but f of x tells us that the function's name is f, x is the input variable, right? This whole piece represents the output. There's more than just a weird f of x name. It actually does tell us something. And soon we'll have multiple functions in the same problem, kind of f, g, h, if we deal with those. So for this one, this looks a lot like the square root of x, right? Which I know that y equals the square root of x looks like that, correct? It has kind of this important point at 0, 0. Well, what I did here is we replaced x with x plus 5. So now I like to remember whenever you mess with the x, it kind of does the opposite is what you would think. But again, notice that if we want 0 as an output, you would put negative 5 in here, correct? So this would be a similar graph, but it would look like negative 5, 0 would be that endpoint. I want to call it the vertex, but it's not really the vertex, unless you think of it as a sideways parabola, but maybe it is. So this would be the graph of this function. Okay. Now, if you knew that in your head, you really didn't have to graph it, because if we want to give the domain now, if we were going to do inequalities, well, we know that 5 works, correct? 5 gives us an output. So does anything to the right. So we would say that x is greater than or equal to negative 5. The range would be, well, we have a point at 0, and then we have a point, every point above it. So we'd say y is greater than or equal to 0. You're also asked to put it in interval notation, just to compare the two. So that would be bracket -5 to infinity. I might even say x is contained in, just to be really thorough there. And here y is contained from 0 to infinity. Does that work for us? Okay. The second one we have here, I think it's still f of x. So f of x equals the square root of x minus 8 plus 2. Why don't you take a second for that one and try to determine what the domain and range would be and what that graph would look like. Okay, so f of x equals the square root of x minus 8 plus 2. So we have two transformations going on in here. Now, our parent function, I guess you might think about, would just be the square root of x. You'll hear that terminology used sometime. But the x in that was replaced with x minus 8. So that means we move 8 units to the right. And then the plus 2 means the whole function is moved up 2 units. Now, if it helps you to sketch it, we can still sketch it. I would just think about the parent function, and I would just move basically the point 0, 0. I'd move it 8 units left and up 2 units and draw the same graph. So if you do that, you can see my extensive, scale usage here. Just label the point. There's that. It's going to go up to the right. Some questions could be tougher with this one, like what's the y-intercept, but we don't really need to do that. Yes?
Would it be 8 units to the right?
Oh, yeah, it is 8 units to the right. Thank you. Thank you very much. I re-negatived my negative thing or something. So there's that. Sorry about that. So it looked like that. Okay. So once we know that, kind of where that important point is at for this type of function, we know our domain will be that x is greater than or equal to 8, or you could say x is contained in the closed interval from 8 to infinity. The range would be that y is greater than or equal to 2, or y is greater than or equal to the closed interval, y is contained in the closed interval from 2 to infinity. Does that seem to be working okay for us? Okay, so let's see here. We could let's look at a couple more here, and then we'll move on. Because number 3 here is the natural log of x minus 2. Now, I would think it's very conceivable that we're not super comfortable with the graph of the natural log of x yet, and that's okay. We might want to go ahead and sketch it first and then use that to translate the other one. Okay, so we have, our goal is to do f of x is the natural log of x minus 2. Now, x is replaced with x minus 2, so that does move right 2 units. I'll have to actually reflect that on my graph, I guess. But if we're not super strong at the natural log right now, we might go ahead and sketch that first. It gives you a couple benefits. It'll help you graph the natural log, and it'll make the next part easier. So the thing we talked about here with natural logs is that the natural log of 1 is always 0. So we know that we have the point 1, 0. We know there's a vertical asymptote at x equals 0. And then we know that if we take the natural log of e, that's going to be 1. Then we're going to get something like that would be our graph. Okay. So now, if we move everything 2 units to the right, that'll just add a 2 to each of these x values. So, and I could put here, we had a vertical asymptote at x equals 0. So now for the new function, you could even think of taking this table and just add 2 to this x and 2 to this x, and you'd have the same graph. And you could move the vertical asymptote 2 to the right. So in this case, have the vertical asymptote would move 2 to the right. So that would now be at x equals 2. The point 1, 0 is now at 3, 0. And the point E1, which was about 2.71, is now about 4.71. It just moves over 2 units. That, in terms of our domain and range for that function. Now, if we just look at the graph, we'll see that our domain is that x is greater than 2, or you could say x is contained in the open interval from 2 to infinity. Our range would be all reals. So you could do that just from your graph if you went ahead and made the new graph. But also, if you knew the domain and the range over here, you're doing the same thing. The x value is just going to move 2 to the right. Right? All reals is still all reals. If you take all reals and move them right 2 units, it's still all reals in terms of up and down. And then we can see that the vertical asymptote switches from 0 to 2. So just a pretty simple transformation there. Oh, maybe, well, yeah, so go ahead. I'll let you just work on these and just go ahead and try these. And I will post the solutions here.